In this tutorial we take on what's known as a dry mixture problem. These are very popular in applications in mathematics and actually do occur quite a bit in the real world as well. So this is one of the best applications to know, in my opinion. And I'll give you a great background on how to tackle any type of mixture problem. But first let's talk about kind of the requirements before we can start this and what group this belongs to. This is an algebra group problem. The skill itself is to solve a dry mixture application where the added amounts are unknown. In other words, we don't know how much of each item we're going to make or add to make this mix. The prerequisites: you have to be very familiar with the problem solving process, which I will actually reintroduce here. You should know either the substitution or the elimination method for systems of linear equations. If you don't know those, the way I solved this initially might still make sense to you, but hopefully you do know those. And finally, you should know how to solve a linear equation in one variable. Now when I look at this, I immediately think, okay, this is going to be some type of application. I should probably write down the problem solving steps, like the ideas that I want to use to solve an application. And while it may seem ridiculous, the first step is always to read the problem. I know that sounds silly, but some people kind of skim through the problem and they don't really get a feel for what the problem is really saying. A second step is to understand what the problem is asking you to do. And in this step, you can do things like draw pictures. You might want to maybe paraphrase what it's saying just to give yourself a better idea of what's going on. But usually, if you can draw a picture, you should draw a picture. The third step is a step that often students miss, and I think it's so important. It's to label the unknowns. Technically, it's to identify and label the unknowns, but I'm just going to say label the unknowns. And that's what I consider to be the let step, because you're going to let x equal or let c equal or something like that. Very, very important step. The fourth step: you're either going to reread your problem, thinking about the variables that you've just labeled, or you're going to look at the picture you've drawn, thinking about the variables that you've used, and you're going to try to create equations using these variables. That's usually the hardest step for students. This is the prime step, but it's also very, very difficult for students. But once you get that done, you should have 1, 2, 3 equations. In fact, a little note here, you should have the same number of equations as you do have unknowns. So in other words, if you have 3 unknowns, x, y, and z, then you should have 3 equations. There's no way you can solve it otherwise. Once you have your equations, you're going to set them up in a system and solve. Or you might only have one equation, solve that equation, whatever. But the fifth step here is to solve. And the sixth step is to check your solutions and state the results. So I just write check and state. Very common problem solving process, but one that's often ignored by students, and it shouldn't be. So jumping into this, let's first read this problem. Sacramento Sweets, which is located at 1035 Front Street in downtown Sacramento, sells peanut brittle for $10.60 per pound and English toffee for $17.60 per pound. These are real prices as of September 19th this year. How much of each candy do they need if they want to create a 40-pound mix that will sell for $12 a pound? And you got to think about this. They have some candy worth a little over $10 per pound, some other candy that's more expensive, and they're going to mix them together to make a candy, a mixture that's priced in between those two prices. So I read the problem, I understand what's going on. I'm actually going to draw a picture for this situation. I have a vat of candy here, and this is the standard picture I draw for this. I have a vat of the peanut brittle, and I also have a vat of the English toffee. And what I want to do is I want to grab some candy from here and grab some candy from this other bag or vat, whatever you want to call it, and I'm going to mix them together. So you kind of think of like walking in the door and just grabbing this entire bag here and grabbing this entire bag, adding them together to create a mix. Now, when some people set up these problems, they tend to set up tables and stuff like that. I've never loved tables. I think tables are a weak way to do these problems. I think pictures are a better way because you see pictures. That's how you view the world, is through pictures. So it's better to operate with something that you normally do in real life. When you show up at a store, you see a bag of peanut brittle. It has a price on it. It has how much it weighs. So that's what we're talking about. So I understand the situation. I've drawn a picture, sort of. Now I'm going to label my unknowns, and I'll label them down here just to give myself some room. So let's think about what we're asked to find. It's usually in the last sentence, and it is right here. How much of each candy? How much of each candy do we need? So what I'm going to say is let, and we have two types of candy. I'll let P equal the amount of peanut brittle, or the number of pounds of peanut brittle. And let's see, English toffee, so we'll let E equal number of pounds of English toffee. And in fact, I use quotes quite often just to kind of quote what I'm using up above, the words number of pounds of, and then English toffee. So now we know what our variables stand for, the number of pounds that we're going to mix here. So now that I've labeled the unknowns, let's create equations using these unknowns. And I'm going to do that using my pictures if I can. So imagine walking into a store. There are a couple things that are going to be on this bag of peanut brittle. The price, which they told us, the peanut brittle sells for $10.60. Oops, that's not right. $10.60 per pound. And then the other thing is how many pounds this actually is. Now, I don't have a room enough on this bag, so I'll just label it below. This bag has, well, we don't know how many pounds, but we let P equal the number of pounds, so this bag has P pounds. And the English toffee sells for $17.60 a pound. And again, we don't know how much we have, but we call that E. E for the number of pounds of English toffee. Now, if they pre-made this mix for us, then that'd be great, because they'd have this already labeled and everything, which they know how much they want to sell it for. They want to sell this for $12 per pound. And they actually say how many pounds they want in this bag. 40 pounds. Now, believe it or not, you're actually looking at the equations. First equation that I see is that P plus E is supposed to equal 40. In other words, the number of pounds of peanut brittle plus the number of pounds of the English toffee should equal 40 altogether. That's what you're making the mix from, is the number of pounds of peanut brittle and number of pounds of English toffee. And that's usually the easiest equation to get. The more difficult equation is to talk about how much money did the person spend on peanut brittle total, and how much money did the person spend on the English toffee total to make this mix. Well, if you have 1 pound of peanut brittle, they spent $10.60. If you have 2 pounds, they've spent $20 plus another twice 60, or $21.20. If they spent if they bought 3 pounds, it's 3 times that $10.60. If they bought 10 pounds, it's 10 times that $10.60. If they bought P pounds, the amount of money they paid is P times that $10.60. So essentially, you're just multiplying these two numbers together to get $10.60 times P. That's how much money total that you spent on peanut brittle. Well, let's go ahead and tack on the amount of money total that we spent on English toffee, which follows the same argument here. It's just going to be $17.60 per pound times the E pounds of it. And that should be the same amount as what we have spent on the mix altogether. 40 pounds at $12 a pound. And this is where students usually flub here, actually. They forget to multiply these last two. So you want to know the overall price of the mix? Well, you have 40 pounds at $12 a pound. So let's go ahead and do that. $12 a pound times 40 pounds. And here are two equations. Now, before I go into solving these, I just want to do a quick advanced check here to make sure that this equation, this last equation, makes sense. The first equation makes sense. First equation, I'm talking pounds. That's what the units are for P. The units for E are also pounds, and the units for this number 40 are also pounds. So I'm adding pounds to more pounds to get a certain number of pounds. That makes sense. If I was adding pounds to dollars, there's no way, there's no such unit as dollar pounds. So that would be weird. So you want to make sure you're adding the same units all throughout. To check to make sure you're adding the same units and getting the same type of units as an answer, in the second equation, the units for that 1060 are actually dollars per pound. And P is just a number of pounds. The units for that 1760 are in dollars per pound. Like I said, this is very advanced, but I'd like you to understand this. The units for E are in pounds. And this back here, the right-hand side, is also in $12 per pound and 40 pounds. It looks as though their units are exactly the same, but what's interesting about this is that you can do a little bit of math here. The words pounds will cancel there. The words pounds will cancel here. The words pounds will cancel there. So this tells you what this equation is talking about. Money plus money is equal to money. This equation is talking about the money. That's the money equation. And that is the pounds equation. Okay? So that's a very advanced way to do this, but it also allows you to check your work. If you had done this, and if you had done what most students that I see do every once in a while, at least, is they forget to write that 12 in. And when they do that, if they would just check their work and say, oh, okay, that's dollars per pound times pounds, dollars per pound times pounds. So we're just talking dollars on the left-hand side. And on the right-hand side, that's pounds? Wait, dollars plus dollars is equal to pounds? That doesn't make sense. I'm missing something. So that's a very important tactic that you can use to make sure you're 100% correct. Now let's go ahead and try to solve this sucker. I went ahead and switched to line paper for this just to kind of have a nice look to it. One thing that I like to do, I don't know if your instructor will force you to do this, but I love to clean up equations prior to doing any work. So what I'm going to do is I'm going to kind of write one extra step in here. In fact, I think I'll split the page so that I can make use of this page as much as possible. What I'm going to do is multiply this second row by 10. The reason why is because then I can move that decimal place over on this, so I get rid of all decimals essentially. So I'm going to go ahead and multiply row 2 by 10, and I'm also going to multiply these two numbers together. Just as a heads up, 12 times 40 is 480. So I'm just letting you know that this number right here is actually 480. And now I'm going to multiply row 2, the second equation here, by 10. So this is my notation for that. It's not just mine, it's a very popular notation. The way you read this is you're multiplying row 2 by 10. So 10 times row 2 becomes the new row 2. The reason why a lot of mathematicians use this notation is so that they can pay attention to what they've done. So that if there is a mistake, they can go back and see where that mistake was made. So I'm just multiplying row 2 by 10, so I leave row 1 alone. 10 times this 1060p becomes a 106p plus 10 times 1760e is just 176e is equal to, and remember the right hand side is 480, 10 times that is 4,800. Always have to multiply the right hand side by 10 as well. Now one thing I failed to mention here that I should probably mention is that notice that we have two equations and we have two unknowns. And that's the perfect situation, having these two equations for these two unknowns. That means we should be able to get a solution. There are two ways to solve a system of equations like this. One would be the traditional substitution method, and the other would be the elimination method. Substitution is generally what's taught first, so I will do the substitution method, but if you stick around, I will also show you how to do this using the elimination method. The idea behind the substitution method is to take one of these two equations, pick a variable, and solve for it. Now, obviously, when you're looking at both these equations, probably the easier equation to work with is that top equation. So let's go ahead and solve for, it doesn't really matter which variable, I'm going to solve for p in that top equation. So what I'll do is I'll subtract e from both sides. So I get the following. P is equal to 40 minus e. And this is called the substitution method because now in my second equation, everywhere I see a p, I'm going to replace it with this picture right here, 40 minus e. So wherever I see a p down here, I will replace it with a 40 minus e. Let me rewrite that equation. So this implies that 106 times what used to be p plus 176 times e must equal 4800. And now that we know p is just 40 minus e, I'll plug that in here. And from this point forward, this is just solving a linear equation in one variable, right? Because this is just a single equation and I only have one variable, e. So at this point, I will distribute that 106 to each of these numbers, or each of these objects, I should say. 106 times 40 is 4240 minus 106e plus 176e is equal to 4800. Combine like terms on this left-hand side, so that's 4240. A negative 106e plus 76e is a positive 70e. And now I will subtract 4240 from both sides. I'll even write that in, minus 4240 from both sides. And I will get 70e is equal to, let's see, 560. And if I divide both sides by 70, oops, well, 7 goes into 56 8 times. These 70s cancel. So I get this beautiful e is equal to 8. I happen to know what e is. And now once you have that answer for e, you can use any of your prior equations that involve p and e to plug that e into. And the one that I highly recommend using is this one right here, the one that you solved for. It's just a great equation to use. So I happen to know that p is just 40 minus e, or in other words, p is 40 minus 8. In other words, p is 32. Now this problem is not done until you state the result. Remember, p is the number of pounds of peanut brittle. So we need 32 pounds of peanut brittle. And e is the number of pounds of English toffee. So we need 8 pounds of English toffee. Now let's check for some logic here. I just want to show you something. Now remember, we need just very few pounds of that English toffee, only 8 pounds of it, and we need 32 pounds of peanut brittle. That should make sense because remember, the peanut brittle is the cheaper mix, or the cheaper candy, and the English toffee is the more expensive. So we want to get only a $12 per pound mix. Well, if you start adding more expensive candy to something that only costs $10.60 a pound, you won't have to add too much of it to raise the average price per pound to $12. Okay. So logically, that kind of makes sense to me. Technically, we're done. You can always stick around. I'm just going to go ahead and show you how to solve that last equation using the elimination method. So how I'm going to do this is to take this equation, or this system of equations here, and I'm going to use the elimination method to solve this. Now the elimination method is a very nice method actually to use on this system, but also substitution is a great method as well, as we just saw. Elimination method, the idea is to make the coefficient of one of your variables opposite the coefficient of that same variable in the equation below it. So for example, let's look at the letters P here. I would love this coefficient in front of P, which right now is the number 1. I would love that to be a negative 106. So what I will do is I'll multiply row 1 by a negative 106. And that'll become my new row 1. Here we go. I didn't touch row 2, so row 2 is still 106p plus 176e is equal to 4800. And negative 106 times row 1 will give me a negative 106p, negative 106e equals, and then negative 106 times 40 is a negative 4240. So that means multiply both sides by negative 106. And then the important part about the elimination method, after you've made these coefficients opposite for one of the variables, is that you add up those rows. So row 1 plus row 2. Here we go. If I add up these rows, I have a negative 106p plus a positive 106p. Those cancel. Negative 106e plus 176e just becomes a 70e. And negative 4240 plus 4800 becomes a 560. Divide both sides by 70, and you'll get that e is 8. I personally like the elimination method a little bit better, just because I think it's faster. But yeah, it's always your choice as a budding mathematician to do whatever you want. By the way, since we know we have 8 pounds of this English toffee and we want 40 altogether in the mix, then I know that the number of pounds of peanut brittle has to be 32. That's it.